Welcome. Welcome, everyone. Thanks for joining. Thanks for joining this VR systems meetup, the first of many, where we will explain and dive deep into the magical world of large-scale VR systems. I also like to welcome some of our speakers of today. David, there you are. How are you doing?
I'm very well, thank you, Dimitri.
Hi, Warwick. Thanks as well for joining.
Hi, Dimitri.
For this, it will be a very interesting session. This is the first of many. We have a record number amount of registrations and people who are already in the call and actually signing up as we speak. So we will slowly get started. Dave, Warwick, I will do a more thorough introduction later in this session. Thanks for joining, and let's get started. So
Okay, speak to you soon.
yes, so the agenda. So we have a packed agenda, and a very exciting one, because in today's session, the theme is to take you beyond the HMD. And well, just for the record, you know, we at Vitalis, we love and we like HMDs, and our software products, they work perfect with HMDs. However, there is another world in the enterprise VR domain where large-scale VR systems are preferred. And it's that world that we're going to uncover today in this first VR systems meetup. So we have three sessions lined up for you. You will see things that we've never shown before, unique footage, unique insights, and also a rare look behind the scenes at one of our customers' installations. So before we start, a piece of introduction. I'm Dimitri. I'm based out of Holland, helping setting up the Vitalis Leadership Network. It's a new knowledge platform where we share stories from the trenches with partners, customers, and experts to help each other advance, and both on an organizational and on a personal level. I'm also happy to see so many of you attending this session as well. So more about VLN, Vitalis Leadership Network, at the end of the show. But let's get started. So I have 1 hour of the three sessions and a 15-minute Q&A. And our meetups are designed for thorough interactions. So we have some serious experts lined up, but we also have very serious experts from our customers and partners, let's say in the meeting today. So share ideas, share your questions, use the comment section and question bar, and keep us posted. If possible, we'll try to address them during the session. I mean, during a presentation, and if not, we carry it over to the Q&A. So please join the discussion, join the interaction. You will see a lot of interesting stuff today. So ask any question you would like us to ask. So yeah, what are we talking about? I mean, we coined it a large-scale VR systems. You know, what are some of the characteristics, and how can they be defined? I mean, you will find, I mean, some of the terms which are typically used. You know, they are large, they are immersive screens. Minimum consists of a wall or multiple walls, and often come in various forms and shapes. You know, you see them curved rooms. I mean, even domes, power walls. You know, most of these systems, almost all of those systems, are bespoke. You know, they're designed to address a very specific function, you know, or a very unique situation, and we'll going to address that today as well. So without tracking, and we will talk about tracking today as well, we call it visualization on those screens. But if you use tracking, it really becomes VR. And in the end, and it's also something which we're going to uncover today, these systems are extremely strong in collaboration. And the reality is, I mean, the fact behind it is that because we have multiple people sitting in the same space, standing in the same space, immersed, in the same model, being aware of your surroundings, being aware of each other, gives a very unique and powerful way of communicating with each other, but also collaborating with each other. So of course, I mean, one can say you can also do it with HMDs, and that's correct. I mean, we also deploy powerful software where people from different parts of the world can very successfully collaborate with HMDs, with headsets, but you're still in your own personal space. So we will share those examples today. What are differences, the pros and cons, and you get the inputs from our experts in today's sessions. This meetup, very quickly, I mean, also to set the expectation. So it is a unique format, and we will try to show as much as possible. It's not always that easy because a lot of the systems we design are so sensitive because of the models or the processes we support. But in this series, we're really going to open it up as much as possible, show you as much as possible, show the capabilities of these systems and our unique knowledge that we have in-house. We are going to look at the bottom line. What does it mean for our customers? While we will be addressing a lot of technical topics, issues, and terms, we will at the same time talk about what is the business value for our customers. And today, I'm very excited to tell you we'll have a very nice look behind the scenes and explanation of some of the decisions, and it will be a very interesting session with things you probably have not seen before. Okay, one slide about Vitalis. So we care about, let's say, empowering our customers' bottom line. I mean, we work for many industrial enterprises with our XR solutions, and ROI, bottom line, is what we are heavily focused on. So the numbers in front of you, it's just one example. I mean, it's from our digital twin solutions, but we have different ROI sheets and detailed explanations for factory layout planning, for design reviews, for service and maintenance. So anyone interested, let us know. So how we are organized, and that's also not known to everyone, is that we operate in two different domains. So we have a software division, and in that software division, we provide powerful software to manage the most complex and difficult models and distribute it to basically any device around the world in a safe and secure way. But we also have our Vitalis systems team who bring in decades of VR systems experience. We installed hundreds of systems in more than 50 countries around the world, and for basically the most demanding situations and customers. So bringing that knowledge together, both on software systems, makes us a very powerful end-to-end trusted partner for our customers. So having said that, and there's much more to say, but I would like to continue on our first session. And that first session is with Paul McCall, and we will invite him live just a little bit later in the show. Paul is having his breakfast as we speak. He's in Orlando at the ITSEC 2021 conference. So before we hand over to Paul, a brief introduction. Paul brings in 70 years of VR experience, also in the engineering world, and is with Vitalis for about 15 years, supporting our customers in designing and delivering the most effective VR system. So let's go to Paul and let us see what he has to say about this. Let's go.
Thank you, Dimitri. Hello, everyone, and thank you for taking some time to connect to the first systems meetup. I'm Paul McColl. I'm systems architect and VR expert on sales here at Vitalis. As Dimitri has said, we're going to take some time during this meeting and other meetings to follow to explore the world of advanced visualization, whether that's AR, VR, XR, or whatever you like. We call it advanced visualization. It covers all of those areas together. So let's start with some context first. And for those that have been in the industry for a number of years, please forgive me for the history lesson. As we know, VR is not new. It's been around for hundreds of years, 180 years, in fact. And 3D photography came along very early in the 1800s. Here you can see an example of that. This was closely followed by holographic projection. This is a technique called Pepper's Ghost. In fact, Pepper's Ghost is still used today. This is how they put virtual people on stage at concerts, for example. This was followed with what looks like an early HMD, where two photographs were put in together and give you a stereographic point of view. And within another 60 years, this had turned into a toy. And for those of you that are old enough like me, I remember one of these from the 1970s and 80s that you can see stereographic images. It's called the Viewmaster. At this time, in the 1930s and 40s, flight simulators were making an appearance. And although really rudimentary, they were effective. By the 1950s, we got the first multi-sensory VR solution. So this was a virtual reality device that had 3D images. It had 3D sound, wind, and smells. A lot of people would call that 6D these days. From then on, development accelerated. So fully tracked HMDs arrived, believe it or not, more than 50 years ago. And no, this isn't some weird medical experiment. It's a thing called the Sword of Damocles. It's an advanced HMD of its time, say back in the 60s. So this developed over a number of years into what I'm wearing here in this picture. That's me in 2010 wearing an HMD that had a 110-degree field of view. It looks uncomfortable. It wasn't really. It was quite heavy, but it wasn't particularly uncomfortable. But it's really not quite an Oculus or an HTC Vive, is it? So at Vitalis, what we've done is we've tried to stay ahead of all of these technological developments. And we've tried to apply these to engineering problems, complex problems, and the visualization of massive data sets for over 30 years. In fact, we've installed hundreds of systems across the world in more than 50 countries and in a diverse range of markets. This makes us one of the world's most experienced VR companies. Let's have a look at how it's used. So for years, you and we all have been putting a huge amount of effort into building ever more complex CAD models. They are high value models, but they're rarely used to their maximum benefit. Even today, CAD frequently stays within the drawing office. Advanced visualization can help companies get away from that. They can help them change that. And it makes the most of CAD. Visualization really makes the most of CAD, or in fact, any complex visual data. So visualization of data can be used throughout the product cycle, throughout your business, right across your factory. It can be linked to your PLM system. It can be linked to your IoT system, so that you can build a digital twin, for example. And it can be distributed right across the business. So we can now use it not just for design, but we can check and develop those designs into something better. We can optimize our factory layouts and plan that beforehand, sort out our manufacturing processes. Those products can then be marketed weeks, months, even years before we ever build anything. Training for assembly can be done. Training for installation or even maintenance planning can be done. And we can start that earlier than ever before. And we can therefore deliver our results better and faster. Don't forget, some of the most complex engineering problems happen right at the end of the cycle. So this could be the decommissioning phase. And in fact, decommissioning is now called repurposing or second life. And this can be planned for, rehearsed, and optimized right from day one. If you look after your product throughout its life cycle and track that product, you can then reuse it later for something else, far more eco-friendly. But the greatest benefits of all are when you build and maintain this complete digital thread. So you have a thread all the way through all of the processes. All of these are combined and all of the use cases are combined, and you use visualization at every stage. To do this, what's required is the ability to see what we need to see, when we need to see it, and with the device that's appropriate to that point in time. What we need is a suite of tools. That's a suite of tools of software, like our Visionary Render or Reach applications, with hardware like HMDs, like AR devices, like power walls and caves, for example. And these will let you do this. This will let you access your data in the way you need to access whenever you want. So let's take an example. This by looking at a number of tools. People use a wide range of tools in Excel. We see HMDs everywhere now. And they're great for personal review and interaction. You can use very large walls, which allow you to interact with your data at one-to-one scale. And they're brilliant for group review. You can get lots of people in front of them. Screens can be made even more immersive by adding a floor. This allows you to look down at the work that might be in your hands or around your feet. This gives you a wraparound environment. The ultimate immersive solution is a cube, and these wrap you on all sides in an ultra high resolution 3D image. There are also portable solutions that let you take these systems on the road. So you can take VR on the road with you, whether that be as an HMD in a small case or as a projection system for a group review in a larger case. A great example of using visualization for design is companies like BAE Systems, who have perhaps some of the most complex products on the planet. Warships, nuclear submarines, aircraft, that sort of thing. And they've been using VR across their business in design and review and manufacturing planning for more than 20 years. These systems allow them to build and test designs well before cutting any steel, and it can save them tens of millions. With more than 20 systems purchased, they are what we would call a large user. VR isn't just for massive global businesses like this. Businesses with only 1 or 2 CAD seats can use visualization too. At this architect in Malaysia, VR technology adds the all-important third dimension. Both designers and clients alike get a better sense of space and volume because they're in 3D. This allows them to evaluate the quality of the spatial volume and allows customers to get an accurate feeling of the space they're going to walk into. And it's this feeling that you just cannot get from drawings or 3D images. You experience your designs for the first time in VR. And I say you experience your designs. You're actually there. You take part in that design for the first time, and that's done with virtual reality. Furthermore, these large-scale projection systems or large-scale screens allow face-to-face group review for designers and clients simultaneously. So let's quickly walk through a portion of the product lifecycle and see where VR might fit. Our designer here is sitting at his desk, running through the design. He's gone through the concept phase of a product design, and he's built his concept in CAD. He can now review that using an HMD at his desk. And as I've said before, HMDs are great tools for personal VR. They're low cost, easy to distribute, really readily available. Quality's improving every month. They give you a 360-degree environment with the right tools as well. You can interact with your data, you can reach out and touch it. However, they are a very personal device, and hygienically, not necessarily something people want to share. So really, all users need their own headset. Now, the low cost of entry of these headsets really helps with this. However, they're not ideal for group review, as we've said before. They can actually limit the communication that people do. So when inside an HMD, you're isolated from the rest of the world. You can't read any facial expressions or get feedback in that way. And this is a huge part of the way that humans communicate. Just think about how a text message can be misinterpreted. When we want to be sure about the message that we're putting in text, we add an emoji of a facial expression. That gets the message across. People know what we're thinking. It's instant. HMDs prevent that from happening. So how do we help? And what's the next step? So he's used this device to look at the designs that he's doing in an environment that's his, at his desk or around his desk. Now he wants to communicate this. He wants to review this design. If these people that he's communicating with are remote, he can do this with advanced cloud-based visualization, like Vitalis Reach, for example. You can learn a bit more about Vitalis Reach in our other series of webinars. And it can be done with a suite of personal devices. We can send complex models to HMDs, to laptops, to tablets, even to mobile phones. But as teams return to the office, things begin to change. There is huge value in face-to-face discussion on top of this remote collaboration that you're getting with your personal device. Face-to-face gives you communication that's far more assured. So large level one-to-one screens like Powerwalls can achieve this. Groups can share in the experience, and multiple locations can connect together and collaborate in real time by linking them in VR. Professional high-end positional tracking systems like optical tracking gives you supremely accurate interaction with VR environment. These tracking systems are flexible and very scalable, so you can track very, very large environments. You can track your head movement, you can track hand and finger movement, you can track multiple people, you can even track tools and parts in the same space as your virtual environment. Powerwalls may require investment and need more space than your HMD, but these systems are far more flexible and can be used for multiple of non-VR uses as well. So you can use them for corporate presentations, customer experience centers, training applications, all sorts of things. Our engineer now has communicated. He shared his design via the cloud and face-to-face. He may well want to take this into a even more immersive environment and surround themselves with the highest resolution possible. And he can do that in a cave. And this level of graphical quality just is not available in an HMD yet. But you have to pay for it. So let's have a voyage around a VR system that actually exists. This is a system that we're building today. It's a current solution with a current client. So what we have today is a floor plan of their building. In the bottom right-hand corner is a red hashed area, and that's phase 1 of the installation that is in process right now. As soon as that's done, we'll move over to phase 2 in the bottom left-hand corner. What are we doing in that space? Well, we are going to put in a number of projection systems. So this is rear projected VR solution. We are also going to move along and add in training solutions to this system. We're going to mix these into a single space. Let's just have a look at that space and how does that actually work. So we'll move through into this room. This is a rear projected VR system. It's set up so we can do large corporate review. Number of seats in the same space. It's rear projected, so there is a mirror and a projector behind the screen. And then in front, we can have the people that are the actors, the users of the system. Now, typically, a system would be viewed by one person, and they would see a view that is tracked to match their point of view. Most people understand that in a tracked system, if you were to move to a different location, if a second person comes into the scene and wants to look at it, they get a distorted point of view. Today, this is accepted by most people. However, we have new technologies that allow us to see the right point of view from the right position. And we call this multi-point of view. So the person on the right sees it from his point of view, the person in the center sees it from their point of view, and the person on the left from their point of view. This is multiple point of view. So we're installing one of these systems, and in this particular case, 3 people can share the same system at the same time. Theoretically, you can do this with 6 people. We've added this to a room where they have some training environments. In fact, we have 2 rooms added onto this. And we can see here that these rooms can be broken and separated so that we have unique training environments. Here we have a number of people who will be in HMDs. Their HMDs can be connected collaboratively, so they can work together, or they can work individually. Their views can be thrown up onto these monitors on the side walls so that everybody can see what they're doing. We have a second room which repeats the other training area so that they do the same work or separate work. They can work individually or they can collaborate together, or the whole room can be opened up into one large environment. In here, we can get 80 people seeing a large VR screen should we need to. That's phase 1. In phase 2, we're adding additional capability. So if we go through the boardroom, we move to the immersive theatre. This is an area where we can bring trainees and VIPs. If we move through to the immersive theatre, we can then get into a larger room where you can do some training. Training, people need to take notes. If they take notes, then they probably want the lights up. Therefore, we have a very bright projection screen. In the front, we have executive seating for VIPs. And in order to get this high quality, bright system, we use LED. LED is a new technology that allows us to throw away the rear projection facility. It's a very thin system, so you can mount it effectively on the wall using almost no space. By saving that rear projection room, you can hand that over to another area. That area could be an area that's used for HMDs, for collaborative review of a number of people together. The room's big enough to have an audience in so they can see what they're doing. But in this case, we're also turning that room over to a cave. So it's a multiple use system. We have a very large platform here to do large scale visualization in an immersive environment. So that's what a real system is going to look like. Let's pop back to the presentation and just complete what we were going through regarding the technologies. Okay, so that's your voyage through VR. What this tells us now with technologies is that projection systems really do add value. And to round up these technologies, we can tell you that things are moving really fast. So VR projectors have always been high complex, high value items. And historically, they come with relatively short life lamps that are very costly to replace. These have now been replaced with laser-based technologies. Laser fits in the same chassis size as the original projectors, but they're far more reliable. They last much longer. I mean, where a lamp might last for 1,000 to 2,000 hours, laser will give you 20,000 hours of life. You'll never buy a new lamp. Downtime is reduced, power consumption is reduced, heat is reduced, quality of image is improved. They run quieter and cooler, and you end up with a much more eco-friendly and economical solution. Some people discount projection because only one view could be projected. But as we've just seen in the model I've shown you, the latest technology has solved that. And we can now do multiple views on a single screen and let everybody have their own point of view and move independently from one another. Other people would claim that space is a problem. That's a big concern these days. And we know space is money, and with reducing office sizes, these days space is absolutely critical. And this has led to the final of the developments that I've shared with you tonight. That's LED. LED walls are the latest generation of VR technology. They're made up of lots of small tiles, so they're immensely scalable. Resolution's amazing, as you can see in this image. Pixel pitches are well below a millimeter now. Brightness and contrast are much higher than ever before. They don't need very much space. They're very bright, which means the lights can be left on. But most importantly, it's this space saving that's critical to most people. So for the main part, this brings my presentation to the close. This is a bit of an introduction for you to the VR in industry, and we'll be expanding on this and digging a bit deeper in future webinars. So we'll go into each of these individual technologies in a little bit more detail. And I hope to see you there. So for now, thank you. And I'll hand.
Thanks, Paul. So, but also thanks to the audience. We will Paul have with us within 20 minutes from now. But thanks also for sharing your questions during the sessions. So keep them coming, please, and we'll make sure they get forwarded to Paul and the team. Sorry for this abrupt transition, but we'll get back to Paul in 20 minutes. So let's move on to our next session here today. And Warwick, can you please join the team while I introduce you? So Warwick is heading our Vitalis systems team, spent about 20 years in the VR and AR industry. Hi, Warwick, there you are.
Hey, Jimmy.
And someone told me you're also an avid, almost professional level clay shooter, but we're not going to get into these details. So let's get down to business, man. So what are we going to see? Can you do a very brief intro on what we're going to show the audience in a couple of seconds?
We're going to go and visit one of our systems that we installed back in 2015, I think. So it's getting on a little bit now. It's very interesting. It's over at Siemens in Congleton, where they make high-speed drives, which are effectively controllers for conveyor belts. And they do a lot of their design and prototyping in this, but also they do a lot of factory layout in there as well to maximize the space that they've got there. It took about 2 weeks to build this from scratch. And as I say, it's been operational since about 2015, minimal maintenance, a really successful system, but it's quite unique in terms of power walls. It's very cost effective for the level of immersion that it gives you.
Wow, let's have a look. Let me start it up 1 second, and Don't give away too much. So, one sec. There we go. So before I run the video for all of you, so I would recommend please up the volume a little bit. The way we had to record this, also with the proper distance showing you everything, the volume is a little bit lower than I think our speaking volume at the moment. So it's 4 minutes, very exciting, and Warwick and I will be back after the video. So here we go. Have fun.
Hi, my name's Warwick Shaw. I'm Head of Systems for the Vitalis Group of Companies. We're here today at Siemens Congleton to have a look at an active wall. So what's an active wall? An active wall is our staple Vitalis visualization solution. We've installed hundreds of these around the world. Typically they're rear projected, they're as wide as the room is and as tall as it's tall. The reason for that is to give you that maximum sense of immersion. Anything in the visualization space that is not part of the virtual solution is going to jump out and your brain is going to say, I'm looking at a synthetic image. Take all those away and your brain will just run with it. So the active wall is typically, although other variants exist, but it's typically a single Dell PC Windows operating system driven system. It utilizes NVIDIA Quadro graphics, and in this case it's pumping out around HD resolution at 120 Hz. So it's really smooth and it's really stable. What makes a active wall a VR solution and not just a visualization solution is the addition of a motion tracking system. In this instance, we're using an ART tracking system. ART are our tracking system of choice. They're excellent, they're really, really stable, really modular. You can add cameras later as your visualization grows. And they come with some really, really brilliant tracking devices. So this one is tracked using a FlyStick 2, really lightweight, about 500 grams, totally wireless interaction device. Really intuitive to use. We've had children pick these up and just operate them straight away with no tuition whatsoever. We pair that to a set of Vitalis ActiveWork glasses and then the ART tracking frame. Again, all wireless. This weighs about 300 grams. You forget that you're wearing it after a short period of time. What the tracking system allows us to do is interact with the virtual world. You can use it quite naturally rather than sort of flying around as I'm doing here. You can actually just walk around these objects and interact with them. And it becomes really, really immersive. But it is very much like looking into a window at times. And to make it more immersive, what Siemens chose to do is add yet another active wall on the floor. Now, what benefit does that bring? Well, what that brings is it allows us to render images outside the screen. So as I'm immersed here, and as you can see the pipe going away from us, in my view, the pipe actually goes right in front of me and then down into the floor. So again, it becomes much more immersive in that I can believe that that pipe is really in front of me. And as I move around, it has all those small adjustments that further support the fact that this pipe really is in front of me. And it becomes that you stop using the tracking device as a navigation tool and start using it as an interaction tool, because your navigation is just done naturally by walking around. So how do we do that? So the screen material is an elasticized polymer. It gives excellent brightness, excellent color uniformity, really reduced hot spotting, so you don't see anything like the projector light intensity right in the center and not so much at the side. But also we pair it to a unique floor material that is a bit of a Vitalis trade secret. We won't be telling you what this floor material is. The floor material, when projected upon, matches the screen material perfectly. The color levels are identical, the brightness is identical, and in this configuration we even make sure that the pixels are exactly the same size. So how do we get those pixels on there? Well, what we have in this case is we have a Christie projector up in the ceiling. and that's mounted to one of our Vitalis custom rigs that interfaces with the building structure. And that fires straight out of there on a nice 1.1 lens, really nice clear optics, and fires into this mirror up here. This mirror, the angle is set perfectly so that the image then falls down in front of you. But why do we set it up like that? Well, the reason is because you want all the shadows behind you. You don't want to see those shadows. Again, anything from the real world that you take into the virtual world will ruin the illusion. And on the screen there, the projector is located behind the screen to get rid of all of those shadows completely. So when I'm using this, there's nothing from the real world that I can see anymore. Okay, thank you very much.
Warwick,
Yeah, sorry
back
about my scratch
again.
end.
So thanks a lot. So are you not going to tell us what this floor material is, seriously?
No, I can't. It's more than my job's worth to me. I can't say what that flooring material is the result of decades of testing. We take into account all the properties that are described in the video, but also its availability around the world, how robust it is, what size the blanks come in, so whether they can match some of the caves that we do. So no, I can't give away the secret of the floor material unless you buy one. If you buy one, then I have to put it on the shipping documentation. So I guess that's one way you could find out.
Okay, I think you just gave away a critical Vitalis trade secret. Okay, so we'll talk to you later in a bit. Thanks, Warwick. Thanks. Fantastic. So, David, welcome. You are joining us from France. So when you fire up your
I'm here.
webcam, there you are. Welcome, man. Thanks for joining.
Thank you very much, Dimitri. Thanks for having me.
Fantastic. So let me do a very quick introduction to the audience. So David brings about 30 years. We have another guru in the house over here in the VR domain. Since you joined, I mean, Superscape in the early, 1990s.
Yeah.
And what I've been told is that when you're not injuring yourself with your fanatic mountain biking, that we can find you do amazing stuff in the motion tracking domain at ART. And what also many people actually don't know is that you also worked for Vitalis. I mean, early 2000s up to 2008, and you were responsible for the turnkey system solutions, and also offering these systems to our defense customers, engineering customers, and for the training world. So I think you're a very welcome speaker and contributor to this event. So thanks for joining.
That's my pleasure.
David, please take over and take us on the journey and all the ins and outs of motion tracking and the importance and relevance when it comes to VR systems. Please.
Okay, thank you. Hopefully you can see my screen here now.
Yes.
Press the share button. Great. Okay. Well, hello everyone. My name's David Clark, and I'm with Advanced Real-Time Tracking. It's a German manufacturer of optical motion tracking systems. We're actually based in Bavaria, which is about halfway between Munich and Innsbruck. So feel free to visit if you're in that part of the world. We're always happy to offer a guided tour. Well, as Dimitris just said, I've been involved in the VR industry since the early 1990s. And at that time, Silicon Graphics, anyone remember them? Powered by huge purple computers that also, by the way, heated the building. And our proprietary systems for flight simulators were the only way to display real-time graphics on large screen projection systems, albeit at a mighty 800 by 600 resolution through CRT beamer projectors the size of a Mini Cooper running at 200 lumens per eye. I know, the Stone Age.
Yeah.
But the thing is, we should commend SGI for their early insight, because these systems established a method of viewing and interacting with virtual reality that's endured to the present day. I'd go so far as to say that even after NVIDIA's innovation placed the last nail in SGI's coffin, there remains no better way for a group of people to gain such a deep understanding of complex information, which then allows them to make well-informed decisions. So on screen, you can see some of the factors that make up the typical large screen projection system. We've gone through this so far, but just to recap, the stereoscopic projectors provide the 3D imagery, of course, and to do that nowadays, they must have a high frame rate and a high resolution. Harking back to what I was saying about CRT projectors, if you got up close to the screen, you could see pixels the size of ping pong balls. But now they're pretty much indistinguishable one from the other. It's just seamless, very high quality, very bright image, be it projected or as Paul mentioned, LCD. You need a big screen typically, and this is to fill the eye's field of view. We don't want intrusions from the real world if we can possibly avoid it, because that tends to diminish the effect. So if we're totally immersed, then we need to be seeing only the 3D graphic images. And the screen configurations can be multiple different layouts. Power wall, a single large screen. Cave, which is multiple perpendicular screens. It can be three-sided in a simple form, and then you can project on the floor, the ceiling, the back wall, all 6 sides to completely surround the user in some cases. On the bottom right image, you can see a format which actually works very well in practice, and that's an L-shape configuration, 2 screens, perpendicular one to the other, and the floor. And it, well, half a cave in effect. It means the user tends to sort of look into the corner, but once you overlay the 3D image, the corner's invisible, and it's a very good way of providing that complete immersive field of view in a relatively small space with excellent stereoscopic effects. To look at the 3D world and get the 3D effect, we use now 3D LCD shutter glasses. The industry's pretty much settled on these. They provide just crisp, reliable, high quality 3D images. Other type of glass technologies are available and have been used in the past, but they tend to induce ghosting and shadowing and such, which of course are completely undesirable. And navigation and interaction in the virtual world. Now, Warwick showed how we can simply move around to move through the virtual environment, but specialist devices also can add other enhancements. So it can provide a means of laser pointing to specific objects. It can allow us to select and pick up and manipulate objects, and also it can allow us to fly through the space as well. And of course, one other major factor is motion tracking. Here we see 2 users collaborating in a virtual environment. They both have tracked glasses, and their position is known in the virtual space. So they can both see the different perspectives on the same virtual environment, as Paul mentioned in his introduction. But what does a motion tracking system do to add to the experience? Well, in a word, immersion. By tracking the user's position and orientation, it knows where they are in relation to the 3D application. And you add this to a stereoscopic display, and it means they can be literally surrounded by the 3D graphics. And if the scaling is correct, they can move around in the virtual space and virtual world with a realistic human eye perspective. And there's something we take for granted here in the real world, and that is something called motion parallax. And this means if a person moves their head laterally, in other words, side to side, objects near to them appear to move faster than those further away. Well, you can try this with your coffee cup. This provides depth cues that add realism and make it easy to determine the relative position of objects. which is essential for accurate interaction. In other words, adding a motion tracking system changes everything. So why not use a head-mounted display, I hear you asking. And for total immersion in the VR application, there's probably nothing better than HMD. You're totally cut off from the outside world with both your sight and hearing fully occupied. However, this isn't necessarily a good thing for longer periods, and personally, I wouldn't want to wear a HMD more than for, say, an hour at a time. And when using a projection-based system, by contrast, not only may the sessions be longer, several people can participate and they can see each other and they can converse normally. Our customers recognize this, and often HMDs are reserved for individual use, perhaps designing assemblies which form part of the larger design, which is then reviewed collaboratively on the big screen system. And finally, of course, with head-mounted displays, there are possibly issues with regard to motion sickness with certain individuals and reluctance to share devices that people just might not be comfortable with. Okay, with limited time, I'm not going to bore you with the history of ART, but here's just a few points that I think are interesting. ART has pretty much been around since the start of the VR industry. And at that time, motion tracking mostly meant recording human movement, which was post-processed for things like movie special effects and specialist applications such as biomechanical analysis. And the ART's innovation at that time was adding the real-time part. In other words, with an ART system, the motion captured movement could be seen within the VR application live as it was happening. And ever since then, we've continued to be the leader in our primary market of industrial visualization, have installed systems in pretty much every country in the developed world in conjunction with our network of partners. Now, one statistic you can see here at the bottom of the screen, courtesy of Barco, is that 80% new car designs are prototyped using ART motion tracking. Now, while I can't verify this for certain, I do know that pretty much every major automotive manufacturer is an ART customer. As I said, it's our primary market. Our first ever sale was to Volkswagen, who remain a customer to this day. But where are ART and indeed other flavors and makes of motion tracking systems used? I've already mentioned our success in the auto industry, and this extends to most areas of high-tech manufacturing. In other words, trains, planes, and automobiles. Sorry. And in all cases, the benefits are largely similar. Communication and understanding of complex data is enhanced by viewing and interacting with the 3D model. And designs can be optimized and faults eliminated without the need for expensive and unwieldy physical prototypes. One other big advantage also is the same data that's used for the design of the product can be further developed and used for other applications, such as ergonomic studies and training applications. On screen, you can see a couple of examples. Top right is Daimler, which is Mercedes-Benz to you and me, where ART finger tracking is being used to check form and function of car interiors. And at lower right, at Toyota Town in Nagoya, Japan, we see a full driving simulator on a motion base. And in this case, we've used a special technique called satellite merger, where the driver is seamlessly tracked both inside and outside the vehicle. It's a good example of the customer-driven, industry-specific tools that we've developed over time that enhance the use of our systems. Okay, onto the commercial bit, which I'll keep brief. Rather than talking about though the ART product catalog, all I want to say here is that ART systems are highly modular, which means that they can be used to optimum effect in pretty much every VR system configuration that there is, both projected and head-mounted display. For example, we've developed a camera that's only 30 millimeters in diameter, so that it can be inserted into a drilled hole, making it virtually invisible in use, and so reducing visual clutter. Because after all, to achieve immersion in VR, the aim is to try and eliminate as many intruding artifacts from the real world as possible. Now, part of our service is to ensure that the specified ART system is the optimal one for the task. So we can create a camera layout simulation for you that shows the type, position, and orientation of the cameras in the screen configuration setting. This means that the motion tracking, once installed, will be as good as it possibly can be across the whole space and takes into account factors such as the number of people inside the volume, as well as other objects such as maybe a seating buck or other physical objects that can affect the line of sight of the cameras. All we need to know from you are the dimensions and type of screen layout, how you want to interact with the virtual world, be it head, wand, finger tracking, or full body motion capture, and an idea of what tasks you want to perform. Then we do the rest. Finally, I can't end the presentation without mentioning our newest edition, of which we are rather proud. Now, following demand from customers for a compact system that can be used in confined tracking spaces, such as a car interior or an aircraft cockpit, we launched only last week the SmartTrack 3 M. Now, M is for mini. It's a very small and robust system that contains the tracking cameras and processor inside a single casing. It can be set up in minutes and is intended to be used in demanding environments such as outdoors in high light level conditions and inside moving vehicles, be they driving down the road or indoors on a motion base. Not only that, with a range of more than 2.5 meters, it's also a good option for tracking smaller projection systems or LCD displays. Here's the data on screen, which I won't read out, but suffice it to say here that it's small, it's lightweight, and like all ART systems, it's very accurate and very reliable. Okay, well that's all for me. Thank you very much for your attention, and I understand that we will take questions at the end of the session. So now it's back to Dimitri.
Absolutely. Thanks, David. So stay tuned, and let me present this one. So a little bit. There we go. Yes. So we are ready for the Q&A, and this panel discussion will be hosted by John Maxfield. Hi, John. There you are.
Hi, Dimitri.
And
hope you can hear me okay.
Second. Yes, loud and clear. Glad having you here on the show. So quick intro for those who don't know John yet. So he's a true VR pioneer, also bringing in 30 years of experience in the engineering and the virtual reality domain. Built a company, also successfully sold one. What I always find interesting and intriguing is that you're a computer science PhD and you wrote your thesis in 1996 on real-time collaborative VR for simultaneous engineering. I mean, so it's always a pleasure having you on the show, and thanks for hosting the panel. Can I also invite Warwick, Dave, and Paul if he's also around?
Yep, I'm
and
back.
So hi Paul. So both John and Paul are now in Orlando. It's morning time. They are at the
same curtain.
IT conference.
Different room.
Yeah.
Yeah, different rooms. I mean,
yeah. We've sprung for 2 rooms.
Yeah. So, but before we start, John and Paul, can you give us any update, the audience, on this conference? I mean, anything special you learned?
Sure. Well, yeah, thank you, Dimitri, for your generous introduction there. I feel I'm not the only pioneer here in the room, I think, because we've got Dave. Welcome to you, Dave, to the panel, and Warwick and Paul. I think between us, we've got many years of experience in this industry. I remember when Dave was mentioning about SGI. Yeah, I used to work for them, so I remember them in the good old days. So I remember all the way back to those huge machines. Yes, ITSEC, we are here yeah, we're not presenting live from the exhibition hall, but it's been an interesting show so far. Lots of interesting technology being presented for basically for military simulation, flight simulators, that kind of thing, combat simulation, but also some interesting new technology from some of the technology providers like Varjo with the HMDs. We've visited Barco, who are introducing new projection technology and LED panels, and JVC have a new HMD that they're showing off at the show as well. So there's some interesting technology, and also visiting quite a few of our customers here, BAE Systems, Lockheed Martin, General Dynamics, Raytheon, and so on, who are all we're all working with, and it's good to see them presenting things and talk to them about how they're using our systems as well as talking to potential new customers for us like Boeing and so on. So it's a really exciting show, so great fun. So I would like to just start. I think we better get started on the panel, actually. I'm just gonna, I mean, obviously there's the four of us here, and as I've been watching the great presentations, by the way, fantastic. What I really like about this is that we've got not just people who have like a 2-year window of experience. We've got people here who know not just the state of the art, but also know can give a perspective on how we've got here today and understand the systems as they've evolved over the years and gone from, you know, the basic entry point. And obviously Paul gave us some insight into the history. Dave has done some as well. It's fantastic to see all this stuff and also look at where we're going. And some of the questions are related to that today. So I'm going to moderate this session now and just say that we've got actually quite a lot of questions, but I don't know if we'll have time to do everything. But I think we'll start with what I hope is potentially an easy one. This is a question that I'm going to ask Warwick to comment on. How easy is LED to install and maintain compared to traditional systems?
So by traditional systems, I assume you mean projection.
Projection, right? I guess, yeah.
It depends what you're comparing, like all things. So if you're comparing a single small projected screen and the equivalent size LED screen, the LED is perhaps a bit more time consuming to install because it's a piece of cake putting one projector on the ceiling and firing it at the wall. As you start to have more and more projectors, the LED array is actually easy to install. You don't need to quite worry about the alignment of those and the positioning relative to each other. The LEDs is effectively just tiling. So you would add all those together. LED is a bit more fragile to install at the moment of install, but once it's there, it stays there. It doesn't drift. So its operational life is much longer and requires less maintenance as it goes along.
Yeah. It's the way, it's the future, isn't it? Really, let's be honest. I think to some extent,
it's the balance of the future. I think is going to go more into LED, and I think even the LED manufacturers who are also projector manufacturers will tell you exactly the same thing. But there's always going to be a place for projection. I think we'll always see it at some point. I'm sure that'll bite me in future. That's my 640K is enough for anyone or whatever it was.
That'll be your famous quote to die with, won't it? Absolutely. Okay, so thanks, Warwick. We've got another question coming in. This is for Dave Clark. Okay, David. It says where Steam might need pucks to track additional objects. How does the art system solve this problem, and how many items can I track in that space?
Well, the principle of operation is that we have multiple of cameras looking at reflective markers, and they are essentially groups of these are in essence shrink wrapped to be a tracked object. The number of tracked objects in the space is probably it's relatively unlimited, but factors are imposed, such as the number of cameras that can look at a number of objects, and they're not occluding or getting in front of each other. But the basic principle is we create a unique geometry of separate markers that becomes a tracked body, and those are all held in the utility software that runs the system, and they cooperate and play very nicely together.
Okay, yeah, great. Okay.
So you can, David, you can attach these markers to any object, whether it be products or tools or body parts, all sorts of things, I guess.
Precisely, yeah.
And I understand you can track larger volumes than sort of systems like Steam. I mean, how big a volume can we get up to with the ART system?
Again, it's in
just
theory,
a function of the cameras, I guess.
but let's say in practice, 10 by 10 meters, I suppose.
Wow.
One of the big advantages here is accuracy in position. So when we are tracking a head-mounted display system, we tend to link with the inertial measurement unit for very fast translation tracking. But for accurate position tracking, then that's where there is nothing better than the optical system. So what that means is, if we take one of our large users of HMD systems, Bentley cars, they have a big space, they have an invisible virtual car in the middle of the space. They can walk around that, well, it's actually 8 by 10 meters space, and they know that they're going to return to exactly the same place, which is critical, so that the view remains the same, especially when there are multiple users. Yeah,
I guess that's that. Yeah, that is really important, actually. We need to make that point. So I've got a quick question now for Paul, just one that's come in a little while ago. I want to bring you in on this one because it's more about the use cases. So someone's asking what type of VR system would we recommend for specifically, for example, training factory workers on assembly lines that are changing frequently? Where would we start with that one?
It was interesting. The project that Warwick was showing you in the video was done pretty much just for that. That was the use case for that system. So they were training people to operate at work cells where they needed to see their hands, they needed to reach out. So they were designing the work cells and then training people to operate them to make sure that people were flexible in lots of different areas, and they could train people and bring up lots of different options of work cell or factory layout there. They did. They're also that client is also in a restricted factory site, so they can't grow buildings very much. So they've used that system for optimizing their factory layout. And again, it's all about how do I work out how to maintain and service things well? How do I get my guys in there to do that maintenance and training? And again, it's worked very well for doing that. So large scale systems are great for doing that sort of thing, especially now with the MPOV, where you can get multiple users in front of a track screen at any one time. But I have to be clear that, as Dimitri said at the beginning, it's not that we dislike HMDs in any way. HMDs are superb for training. It's great for getting lots of people up to speed very quickly, and they're very distributable and low cost to do that. But if you were doing something in front of a group, and you needed to discuss that process, that training process as a group, or if you had an instructor, then then a large screen works really, really well.
Yeah, and I think also the software you couple that with is important choice as well, because picking up on that, the last point of that sentence in terms of an assembly line that's frequently changing, I guess you don't want just a pre-built bespoke point solution with one training environment. You need something where we provide, I guess, a system with a platform and a piece of software that can be adapted quickly, and something where they can change the components of that training system quite quickly as well. So we've got to take those things into account, because when it's in the process, there's no point providing something that's out of date. Training process that's out of date within 3 months. They need to be able to adjust it and train it. So it's not just about, it's about taking that whole solution approach and saying what parts are we integrating in terms of what kind of display technologies, what tracking systems do they need. The whole use case has to be taken into account, including the process and how we do it, just to kind of pick up on that question. So we need to couple, we need to put together the right solution that delivers end to end a complete solution, I think, as well. This is really important.
Absolutely.
Yeah. Okay, so we've got another question. I think, let me just check. Okay, so this is another one for Warwick. It says, we love the wall and floor system. Great, we've got a positive review. Does this require much additional support and maintenance over a standard power wall? I guess that means by a single screen. And how does that build compare to a cave? Okay. So.
No, it doesn't actually. You think it'd be double the maintenance, but it's not, because you've only got one tracking system, and you just have to manage that one join between the two projectors. Projectors drift over time because of environmental reasons, typically heat and vibration, those kind of things. So you may have to realign those projectors. We build in all the tools for you to do that as easy as possible. But you have to manage that alignment of those two things and make sure they're synchronized. They tend not to drift too much, but it is possible that they do drift. So that's the only extra maintenance activity that you have to worry about with that.
I think it's worthwhile, Warwick, saying that we're now exploring LED wall and floors, so that drift issue has gone away completely.
Yeah. Okay.
And I think there's a second part of that. How does that compare to a cave? A cave is obviously you've got to manage the alignment of several places to each other, and they're all touching in two places. So that does make it a bit more tricky, but there are other ways to get around that.
Okay, good. Thank you. Okay, well, I've got another question. I think we can only probably fit in a couple more, but depends on our time limit. Dimitri, have we got much more time, or have we got time for a couple more?
Yes.
So. Okay, good.
Take two more, and yeah.
Okay. Okay. So this is a question that's probably both, I guess, David and Warwick could pick up on, I'm guessing. So there's a question from someone saying our HCR product uses a magnetic field tracking system which suffers from interference from the metal content of the building. Is it possible to modify the tracking system to be an optical one? I guess modify or replace. I guess those are the two options.
Yes, modify. I think no. But replace, well, certainly. I mean, of course, an optical system by its very nature is immune to magnetic and interference of objects which are perhaps metal or perhaps a source of magnetism, motors and such.
Yeah.
And it doesn't have many moving parts. It's inherently reliable. The system once set up, it tends to be very stable in operation.
Okay, and I think the HCR product, I assume, is referring to the helicopter crew training products. That's something where we've used ART tracking several times, isn't it? Really, in quite a few installations. So I guess Warwick, have you got any more to add to that one?
I can see that
the application of HCR.
Yeah, I can see the question. It's from Pete Booth. Hi, Pete. Yes, so at the time, the way to solve it was with Polhemus. ART didn't quite have the camera with it wasn't possible to fit the camera within the cabin at the time. But since then, ART have jumped forward and they have much smaller cameras that David mentioned. And I think I would solve the HCR problem in a totally different way now. And that probably will be with ART.
Yeah, the big advantage of the Polhemus system is that the tracking emitter is a cube and essentially emits a sphere, and that's ideal for helicopter based applications in principle, where the guy in the back is inside the helicopter, but his method of operation is to put his head and half of his body outside the door and look underneath and around the helicopter. Yeah. That's a little bit of a challenge for a camera-based system. But as Warwick said, systems have shrunk and it's much more adaptable. And actually, we have some very nice examples of exactly this available from one of our US or Canadian customers, who is a major manufacturer of aircraft training simulation systems.
Yeah, we're seeing a few of those over at ITSEC at the moment, really. So yeah, there's a few people. There's a few people using the RT system, I think. So we've seen a few of examples. Great.
So John, let's try to
just
wrap
one
it
more
up.
question.
And one final question. I mean,
okay, yeah, well, we've got one final question, which I think is quite an important one, because I don't know if we touched on this, but it's a question. It's very short, right? For handling MPOV, do you need a specific kind of niche kind of projector to do this, or is there multiple manufacturers who provide these things?
So I'll jump in. I'll say, yes, it's a niche projector, but there are several manufacturers that offer different types of solutions. So there are a couple of manufacturers that do a dual view MPOV solution, and there is one manufacturer that goes beyond that and does 3-view solution at the moment. It is a fairly specialist machine, and the way that you drive it as well is a little bit more complex, but the value it adds is enormous. And this is, you know, this is what we're getting with this client that we showed the model of in the presentation. They wanted to get multiple people to discuss something face to face, but have their own unique views. I mean, they could have their own unique views of a single product. They could indeed have their own unique views of 3 completely different products. It depends on how they want to work, but the system's very flexible.
Okay, thanks, Paul. Yeah, so there are a few more questions, but I think we'll deal with those offline. We'll send responses back to everyone who's asked questions. I guess it just remains for me to thank everyone for their contributions to this discussion. It's really helpful, and I think you can see that within this team, within Vitalis generally, there's a huge wealth of experience to deal with all these types of systems and create these bespoke systems that integrate and really address people's needs. But you need that experience in order to build these systems. You can't just kind of just pop up a system overnight. They take years of experience to build and refine and get right, and get that experience to get that right. And we are, you know, we've got this expert team who can answer all these questions now. So feel free to fire off questions after the webinar if you want, and well, I'm sure our team will be happy to answer any of them that come up. So I'll hand back to Dimitri now. Thank you very much for indulging me for more time than I would deserve, but thank you.
John, man, thanks a lot, John. Let me go ahead and close the this meetup. So thanks to you, special thanks to Dave being our guest, and of course thanks to Warwick and Paul, but moreover thanks to all of you who joined us today. We will be celebrating a record number of people who registered but who also joined, and that is making all of us very happy, because it means that we are creating value. The fact that you say it is a very important thing to us. So a couple of closing notes. So for those of you who like to stay tuned with us, so please follow us on LinkedIn. We are sharing product updates, but even more important, other events and information. I think it's our most active channel. So stay tuned, follow us, and stay posted on everything what is happening. And for those of you who have not yet registered, and I'm referring to our customers, Vitalis customers, and separately also Vitalis partners, please do so on our website, because as of next week, we will be kicking off the first VLN customer event. And in the week after that, our first kickoff inaugural event for our partners. So please join, because this session is for you, from you, and to share knowledge, to help each other advance. And we're also opening specific working groups on the topics which you'll see below. And if you have other topics that you consider interesting to spread the word, to discuss, then let us know. So this is not a pure Vitalis thingy session. This is specifically also for our partners and customers. So hope you'll sign up and join us, and I'm more than happy on behalf of Vitalis to see you there. So finally, I mean, those of you who are triggered by what you saw today, also check out the website. Let us know what you think, what you're thinking about. Get in touch with us. Read some of the case studies which are out there, some of the systems that we also put in there. And I mean, that's it for now. I can also be very happy to have you here. we want to see you back, and I'm going to close this session. So thanks again to all of you, Dave, Paul, Warwick, John,
Thank you.
and all of you
Thank
out
you.
there. So
Thank you. Bye-bye, everyone.
Thanks, everyone.
Bye.
thanks a lot.
Bye now.
Have a great day. Thank you.